There we go. So mark your own. Let's bring up my pens. We'll get our favorite student again, good old Ann. Solved by graphing. So on your test, I'm going to give you one or, well, you know what? I'm going to give you 2 or 3 solved by graphing, probably 1 in slope-intercept form, and 1 or 2 won't be. Yeah, I have to rewrite it, or I'll give you point-slope form, or we got all sorts of ways to graph. This first one is in slope-intercept form. It's got a y-intercept of 1 and a slope of 4 over 1, which means up 4 over 1, up 4 over 1. And if I go back 4, you know what? It looks kind of, sort of, kind of, sort of like that. The second line is also in slope-intercept form, has a y-intercept of -8. Now, when I try and graph this, it's down 5 over 1. What's the problem, Mac, with going down 5? Okay, I'm off the page. So down 5 over 1. I also got to clue in that I can go back 1, up 5, back, right? Back 1, 1, 2, 3. Oh, they cross right there. Back 1, 1, 2, 3, 4, 5. Right there. They cross right there. The point is -1, comma, -3. I made that worth 2 marks. I can't help noticing there's an x coordinate and a y coordinate. 1 mark for each of them, as long as you found it by graphing. If you didn't put any graphs there, then I'd take a mark off, even if you got the right points. Every year in grade 11, I had some students, Logan, they couldn't remember, or they hadn't ever learned, or they just didn't bother trying how to graph, but they could find substitution or elimination. So they would solve that using substitution or elimination. They would get the points, but they wouldn't graph it right, in which case I'd give them 1 out of 2. You with me? Nombre dos. This one here, if I get the y by itself, is y equals, I can plus the x over. So it's got a y-intercept of 2, and it's going up 1 over 1, up 1 over 1, up 1 over 1. I'll graph that much. I may need to lengthen the line, Tawny. I don't know. It all depends on where they cross. This second one, oh, I could just plus the y over. This is actually y equals 3x. Which means it has a y-intercept of 0 and a slope of 3, which means up 3 over 1, up 3 over 1, up 3 over 1. You know what? That's a terrible freehand drawing. I would use a ruler, but I can tell you, they cross there. They cross at 1, comma 3. Yes? 1 mark, 1 mark. Number 3 says solve by addition, subtraction. If you solved by substitution, you're going to lose a half mark no matter what. It says solve by addition, subtraction. This is the elimination method. I think what I'm going to do is I'm going to call this equation 1, this equation 2. I'm going to rewrite equation 1. But I'm going to multiply equation 2 times 4. That's going to give me a negative 4x, a negative 2y, and a positive 14. You can get rid of the x or the y, whichever one is easiest. You could have gotten rid of the y's, and I'll walk you through that in a second, but for now, I think it's easier to get rid of the x's. Or you could have multiplied the... No, well, we'll leave it at this for now. Yep.
Wouldn't it be a positive 8y?
Wouldn't it be a positive 8y? Because I'm multiplying everything by 4 like an idiot and suddenly botched that totally? Is that what you're saying, Tony? I would agree with you. How about we do this? Multiplying everything by 4, it's going to be a positive 8y. I was just changing the sign for some dumb reason. Like I said, it's easy to make mistakes in this. And then negative 14 times 4 is going to be negative 56? Whew, boy. Thank you for catching that. Add. I can do that, okay. 14y equals negative 56. Divide by 14, divide by 14. I think y equals... That gets you 1 mark. Oh, I'm going to plug it into that equation. Now, if you don't want to do a big arrow because you're running out of room, but you still want to show your work, I could just say plug it into equation 1. I'll figure out what you did, and that also is organized for me as well. That's why I always label them equation 1 and equation 2. It takes 2 seconds. I'm going to get this. 4x plus 6 bracket or times negative 4 equals 0. 4x minus 24 equals 0. 4x equals 24. Hey, x equals 6. How many marks did I make this worth? 2. How many things did we find? Hey, what a coincidence. How about 1 for each? 1 mark for each is how I'll probably mark these. And if you did substitution, half mark off. You need to know both, because I will definitely give you some that you can't solve with substitution. And probably, talking to most of you have picked up my bias. I like substitution better, but Rachel, it doesn't work for everything. Elimination is the one that works for anything, even if stuff doesn't work out evenly. 4. Yeah. I think I'm going to get rid of the x's since one's positive and one's negative. You could get rid of the y's. Wouldn't be wrong. I'm going to get rid of the x's, and I can already tell you I'm going to need lots of room. I'm going to divide this in half. I'm going to multiply equation 1 by 8 and equation 2 by 11. And some of you may have noticed, Grayson, while doing the homework for the elimination method, a shortcut that always works is if you multiply the first equation by that coefficient, and if you multiply the second equation by the first coefficient, as long as they're opposite, positive and negative, that'll always cancel. It may not be the smallest numbers, but it'll always work. And I'm not fussy. So when I do that, I will get negative 88x minus 16y equals negative 23 times 8 is going to be 160 and 20, 184. Big numbers. I got a calculator, no big deal. Although I did it in my head. Times 11, it's going to be positive 88x, the 11 times table I know how to do, minus 33y equals negative 110. Add. I'm going to get negative 49y equals negative 294. Is that right? Oh, please tell me this works out even. Have I made a mistake? No one? Because I'm the king of that. Please let this work out evenly. Or at least to a nice fraction. Ah! I doubt that's a fluke. Y equals 6, and I proudly put a box of Triumph around it because that took a lot of work. Which equation do you want me to stick it into to find x? 1 or 2? I think I would choose 2 only because in front of the x is positive, and as you may have noticed, I make dumb mistakes with negatives. You saw that recently. So I'm going to plug that into equation 2. So I'm going to get this. 8x minus 3 bracket 6 equals negative 10. 8x minus 18 equals negative 10. 8x equals, what will I do with that minus 18? Add it. And by the way, you'll notice I'm skipping some of the last few steps. Sarah, I am totally okay. You with me? I am totally okay with if you reach the last couple of steps, because you've been doing equation solving since grade 8, really. If you're comfortable. You don't have to, but I'm kind of nudging you that way. I'm big on shortcuts. 8. Someone said 8. Are you saying that x is 1? Are you saying the answer is 1, 6? By the way, let's suppose this was a test and you just finished the test and you have half an hour left. Do you hand it in? No, instead you get your calculator out and you go to this first one. You can go negative 11 times 1 minus 2 times 6. Hey, that works out to negative 23. 8 times 1 minus 3 times 6. Hey, that works out. I know I'm right. Guaranteed I got 2 out of 2. Kind of a nice feeling. Go back and check your answers. Mr. Dueck, what if I checked my answers and they didn't work? Jordan, have you been doing the homework? Yeah. Have you made some silly mistakes and you couldn't figure out where or what? So here's your strategies. Start over, but instead of getting rid of the x's, try getting rid of the y's. And if you're lucky, you won't do the same dumb mistake twice in a row. It's an old trick, Mac. If that doesn't work, try solving it with substitution. Even though you won't get full marks, you might be able to get the correct answer and check, see if it works. Then go back, and now that you know what the answer is supposed to be, you may find where you zigged. You may be able to track down why yours didn't work out the way it should. So you got, Sarah, lots of tools here. And again, sorry, there is also equally lots of room to make mistakes. 1 mark, 1 mark. Substitution, I rewrote this to get the y by itself. Y equals 3x plus 1. I plus the y over to get it to the right-hand side, and I plus the 1 over to get it to the left-hand side. And Brandon, I did that all in my head. And I'm going to stick that into there. So it's going to be 4x plus 3 bracket 3x plus 1 equals 29. Kenzie, we called this the substitution method because you're substituting one equation into the other equation, but you got to get a letter by itself first. Now what? Felt sad. No fractions, but expand and gather like terms. So I'm going to get 4x plus 9x plus 3 equals 29. I'm going to get 13x plus 3 equals 29. I'm going to get 13x equals 26. I get x equals 2. The substitution method, a little more work to find that first answer. 2 extra lines usually. But what I like about it is I can almost always find the second answer in my head. Logan, my friend, read me that equation right there, the y equals equation. Read me this.
Y equals 3x.
But what did I just say x was? Y equal, Logan, what's 3 times 2?
7.
Hey, what's y, Logan?
7.
Where do these two graphs cross? What, comma, what? 1 mark, 1 mark. Oh, half mark off if you used elimination instead of substitution. Turn the page. You know what? In number 6, I could either get the y by itself in the first equation, or I could get the x by itself in the second equation. It doesn't matter. Which one?
Y?
Who got the y by itself? Who got the x by itself? I'm sensing a lot of people didn't do the quiz. That's a bad thing. To be honest, I would probably get the x by itself because I think you get a bit of a nicer equation. I think I would say x equals 2y minus 17. And then I would go like this. 4 bracket 2y minus 17 plus y equals 31. 8y minus 4 times 17 is 68. Thank you. Wow. Plus y equals 31. 9y minus 68 equals 31. Oh, please let this work out okay. 9y equals, add 68 to both sides. Oh, whew. 99. Are you saying that y equals 11? And are you saying that x equals 2 times 11 minus 17, x equals 5? I better write this in the correct order. 5, comma, 9, Mr. Dueck? 5, comma, 11, Mr. Dueck. 1 mark, 1 mark. Solve by any method. Let's get rid of brackets. First things first, I would take equation 1 And I would rewrite that as 5x minus 6y minus 12 equals 31. I would say this is really 5x minus 6y equals 43. That's equation 1. Is that right? Double check. Minus 6y minus 12, and then you'd plus the 12 over, and yeah, it looks good. Then I'd take equation 2, and I would go 6x plus 42 equals 4 minus 4y. I think I would plus the 4y over, and I would minus the 42 over. I think when I do that, I'll get a 6x, I'll get a plus 4y equals a 46. Is that right, folks? No, minus, Mr. Dueck. 4 minus 42. It equals a negative 38. Is that right? That's equation 2. Did I leave lots of room? Whew, good. I don't think substitution's going to work. I think elimination. Let's get rid of the y's. So to do that, I'm going to multiply equation 1 by 2. That turns it into a negative 12. You could also multiply equation 1 by 4 and make 24s there. That's the quick and easy way. Yep. 10x minus 12y equals 86. Double check, double check, double check, double check, double check. Yes. And I'm going to multiply equation 2 by, what I want it to be a 3. 3. That's going to give me a 12 there too. So I'm going to get 18x plus 12y equals negative 90 and 20 for 114? Better double check. Yeah? Really? Or are you just saying that to make yourself look? Okay. By the way, if you made them 24s, I think every one of your numbers would be twice as big. You'll have a 20x minus 24y equals 172, and you'll have a 36x plus 24y equals negative 228. Yeah, yeah. Oh, you just got an extra factor of 2, and you'll end up dividing it out later. My numbers are smaller, but not much smaller that it's hardly worth it. 28x equals, you know what, my brain. 86 plus negative 114. Oh! Holy smokes! Whew! Let's go find y. I could plug it into the typewritten equations up there. That's going to be a lot of work. I'm going to plug it into either equation 1 or equation 2 as I rewrote it. I think I'm going to plug it into equation 2. So I'm going to get 6 times negative 1 plus 4y equals negative 38. I'll get negative 6 plus 4y equals negative 38. I'll get 4y equals negative 32. Holy smokes, this works out evenly. I get y equals negative 8. Is that right, humans? So answer, negative 1, comma, negative 8. That's where those guys cross. Mr. Dueck? Yes, Rachel. Are you going to put like 10 of those on your test? No. You know what? Probably 1 with brackets, yucky. Maybe 2. And 1 with fractions, yucky, like the next one. Or maybe 2, but not more than that. 8, solve by any method. Felt sad, clear fractions first. First thing I'm going to do is I'm going to go times by 15, times by 15, times by 15. Here's my new and improved equation. It's going to be 10x minus 12y equals negative 18. That's equation 1. And I'm going to times by 4, times by 4, times by 4. It's going to be 2x plus y equals 10. What do you want to do? Substitution or elimination? Substitution? Yeah, you know what? We can get a y by itself. Sure, let's go substitution. Either's fine. I'd give you full marks for whatever method because I said solve by any method. So you're saying I can rewrite this as y equals 10 minus 2x? Yeah, Nate? And I can then stick that into equation 1. So I'm going to get 10x minus 12 bracket 10 minus 2x equals negative 18. I'm going to get 10x minus 120 plus, come on, pen, plus 48x equals negative 18. 24. Wow. Dueck. Wow. You do get 34x minus 120 equals negative 18. You do get 34x equals positive 102. Tell me you get x equals 3. Is that right? Wow. Oh, hey, but I can get y. That's going to be 10 minus 2 times 3. It's going to be 10 minus 6. Y is going to be 4, 3, comma 4. How many marks did I make this one worth, Mickey? 2. It really should be worth more because it's a lot more work. And probably on a test, I would make it more. My only concern is, Jacob, I don't like making harder questions worth more marks because then when kids have trouble with them, it's really hammering you in the marks, even though I know it's harder to do and it should reward. Anyways, so that this quiz is out of, count 'em, what? 16. Give yourself a score out of 16. So I kind of hinted about what types of solutions there were. Anyways, here we go.
Yeah, we don't have that.
You have assignment 4? I didn't give you the notes? Well, I guess I gave you the homework instead of the notes. Let me give you the... Okay, we're back after a little photocopying snafu. Ready? Quiet, please. Investigation number 1. It says, state the number, or graph each of the systems of equations and state the number of solutions. So let's look at A. That is a y-intercept of 1, 2, 3, 4, 5. And the slope of up 1 over 1, up 1 over 1. It looks like that. The second equation, what's the y-intercept? Positive 1, what's the slope? Negative 1, so it's going to go through positive 1. It's going to go down 1 over 1, but since I want to find where they cross, where do they cross? Negative 2 comma 3, but that's not what the question really asked. The question really asked, how many solutions are there? How many? 1. One unique solution. Take a look at B. What do you notice is the same about both of those lines before graphing it? Same slope. What's different? Y-intercept. I already got J. You're right. There's going to be parallel. No solutions. But let's actually graph it just to convince ourselves. So we have a y-intercept of 6. 1, 2, 3, 4, 5, 6. And that means up 2 over 1. Like that. And we have a y-intercept of -8, which I'm not sure, does that fit? 1, 2, 3, 4, 5, 6, 7. Ooh, it does. And then up 2 over 1. And we would say no solutions. And you already, I think, Brendan, figured out how we can recognize it. If they give you a system and weird stuff is going on, hey, try writing it in slope-intercept form. And if they both have the same slope but different y-intercepts, they never cross. You might not have noticed it because they didn't give it to you in slope-intercept form. But what will happen is if you try substitution or if you try elimination, your x's and y's both suddenly end up canceling. You get no x's and no y's, and that usually gets people, wait, what happened to my variables? Hey, these are either overlapping or parallel. Which one? Rewrite them in slope-intercept form and figure it out. C. Now, this first line is in slope-intercept form. It has a y-intercept of -2 and a slope of up 3 over 1, up 3 over 1, up 3 over 1. This second line is in general form. However, I think I can get the y by itself. I would plus the 2y over to that side, and I'll have 6x minus 4 equals 2y. And then if I divide by 2, divide by 2, divide by 2, I get 3x minus 2 equals y. That second equation is actually that. And what do you notice about that compared to the first equation? Not just the same slope, but also the same y-intercept. They're identical. I'll graph it. I'll graph it in black. How many places do these lines cross? Yeah, everywhere. Infinite. Okay, so how many solutions here? We would say infinite number of solutions. Or here's the fancy phrase. We say these lines are, here's your new word, good spelling, Mr. Dueck, coincident. A coincidence in English is when two things happen at the same time that are very unlikely, but they happen at the same time. Coincident lines are when two lines happen to be the same line at the same time. If you're looking for a way to remember that word. Yep. Could you not just put a sideways 8? You could say, well, you got to be careful. If you wrote sideways 8 number of solutions, yeah. If you just wrote a sideways 8, you're saying the answer where they cross is infinity. You've got to be careful. This is asking how many solutions are there, right? Does that answer your question okay? Nice call with the sideways 8. So, in all of the examples, each system that we've done so far, systems have had one unique solution. Usually worked out evenly because I made them work out evenly, but Rachel, if they worked out fractions, we dealt with it. Now we're saying, you know what? It may have no solution, one solution, one unique solution, or an infinite number of solutions. And you can figure it out by rewriting them in slope-intercept form. Turn the page. Rob, this is for you. Except that's a pretty terrible infinity sign. Let's try that again. By the way, what is an 8 on its side the shorthand symbol for? Okay, infinity, because you're saying it keeps going forever and ever and ever. You can kind of imagine that. So, number of solutions. Let's make up a graphical example of something that has no solutions. I'm going to make up the first equation. Y equals -2/3 x plus 4. Can someone make up another equation that would give us no solutions? Sure, go ahead, Brendan. How about this? Y equals
Negative
negative
2/3
2/3 x plus 6. There you go. Slopes, same. Y-intercept, different. Okay. Let's make up ones that cross. All we have to do is make sure the slopes are different. But I'm going to write them the way we're used to seeing them in this unit, which has been something x plus something y equals something, something x plus something y equals something. 5x minus 3y equals 7. Do you know how I can guarantee that these two have different slopes? Make sure the coefficients are different. 4x minus 3y equals 12. Those will cross somewhere. I don't know where, and I doubt that'll work out evenly. But trust me, if you rewrite that in slope-intercept form, okay. So slopes, different. Thank you. Okay, and what did we say for infinite? We're actually going to fill in the bottom row first. If it's an infinite number of solution, the slope is the same, and the y-intercept is the same. And you've already figured out how to spot that in slope-intercept form. I'll show you how you can spot it when it's written in systems of equation solving form. Watch. 5x minus 3y equals 7. Same equation as before. Here is the same equation. 10x minus 6y equals 14. What did I do? If you notice that the two equations are actually like factors of each other, basically, trust me, when you rewrite it in slope-intercept form, they'll end up being the same. You don't have to memorize that. What I've just done, though, Anita has given you a shortcut. If you spot it in that form ahead of time, you can save yourself rewriting it in slope-intercept form. Can you survive without that? Just fine. So, example 1 says, without graphing, figure out how many solutions there are. Let's, in A, rewrite this in slope-intercept form. How would I do that? So we're going to get 5y equals negative 3x plus 15, and then what? Divide by 5, you'll get negative 3 over 5x plus 3. Oh, how does this compare to the second equation? Exact same, not just same slope, but what else? Same y-intercept, right? So these are, fancy word, coincident. I'll write that down just so that you see it. Or, for Rob, infinite number of solutions. B, none, one, or many. Well, let's rewrite that first equation in slope-intercept form. How? I would plus the 4y to that side, and I'll get x plus 8 equals 4y. Divide by 4, I'll get 1/4 x plus 2 equals y. Oh! Coincident. That's quite a coincidence. That's how I remember the word, by the way. Infinite number of solutions. Without doing any work in your head looking at C, none, one, or infinite. These are going to cross. You know why? Because those coefficients have nothing in common, right? Trust me, if you rewrite it, you're going to find different numbers in front of the x each time, but I'm telling you, that's going to be one solution. Curtis, it's a nice time saver because it lets you know ahead of time, do you even want to try? Turn the page. Example 1 says, determine the number of solutions of each linear system. Okay. How many you notice it's not saying solve. You could, but it's saying don't bother solving. Just tell me how many answers there are. In A? Infinite? How do you know? Let's see if I go the shortcut, times by 2, times by 2, times by 2. It's the same equation in disguise. And if you rewrite those in slope-intercept form, trust me, you'll get the exact same equation both times. Again, can you survive without that shortcut? Yeah, because you all know how to rewrite stuff in slope-intercept form. But you may have picked up by now, Nathan, I'm big on shortcuts if I can show you something clever. So this is coincident. That's quite a coincidence. Infinite number of solutions. What about B? That one I can rewrite in slope-intercept form pretty good, yeah? I think plus the y over and plus the 1 over at the same time. 6y equals negative 4x minus 10. How would I get the y by itself? Divide by 6, and what's that going to give me in front of the x? Is it going to give me a negative 2? So what can you tell me about the slopes? Same or different? So cross or not? They have to, somewhere. They have to. If they got different slopes, they got to cross somewhere. I'll walk you through it. Divide by 6, divide by 6, divide by 6. Y equals negative 2/3 x minus divide by 2, 5 over 3. You know what? One solution. Those guys cross. I don't know where. I'm telling you they cross. C. C. Zero? You think they're parallel? Convince me. Okay, so you spotted a shortcut. We can rewrite this in slope-intercept form, but Brandon is saying, you know what? I noticed they went times by 2, but not times by 2. That's how you can also tell they're parallel, if you spot that. But let's rewrite it in slope-intercept form quickly, because this isn't too bad a one. This is going to be y equals negative 3x minus 1, minus 3x from both sides. And this is going to be negative 2y equals 6x plus 12, divide by negative 2, divide by negative 2, divide by negative 2. It's going to be y equals negative 3x minus 6. So that's the second equation. There's the first equation. And Brandon, you are correct. Same slope, not the same y-intercept. Parallel, 0 solutions. Is that okay, Jordan? Or you have? Yeah? Yeah. Example 2. Example 2 says solve by graphing. Have we done a bunch of solve by graphing?
Yes.
Yeah. All I care, I'm not even going to do this. Look at the equations. Do you think they cross, overlap, or are parallel? Take a look at them. I think I can do some of the math in my head. If I try and write it in slope-intercept form in my head, they're going to cross somewhere. Skip it. What about B? Cross, parallel, or overlapping? Parallel? Let's see, if they're parallel, what did I multiply the x by to change it into that? 3. What did I multiply the y by? Also 3? Then they're not parallel. And I'll convince you, I'll prove it. Let's rewrite these in slope-intercept form. This here I would plus the y over and I would plus the 1 over. This is y equals x plus 1. Here I would go 2y equals negative 3x plus 12. Divide by 2, divide by 2, divide by 2. Y equals negative 3 over 2x plus 6. Same slope? Nope. Then they're going to cross somewhere. And although the question says solve, Rachel, I've done a bunch of graphing with you. You want to give him an elbow? He's going to need it. Give him an elbow. He's alive. I could find where they crossed. Have we practiced substitution a whole bunch? Yeah? So I'm not going to make you do A and B. We practiced this. I'm not going to make you do C. Because I think all of these would have solutions. I'm looking, none of these are parallel or coincident. Meh. I'm going to say this. Work on assignment 4. All of it. Now, I'm in the process of making up an answer key. I'll put it online and I'll have it here next class, but I'm about halfway done.